Start today's class. Okay. Can you see the screen?
Yes, sir.
Yes. Okay. Still it is visible, right?
Yes.
Okay. Okay. So today's revision class is for aldehyde, ketones, and carboxylic acid. Okay. So the first thing that I want to do is copy these molecules. Okay. Copy these molecules and tell me. So if I label it A and I label this as B, I label this as C. Okay. So we have three different structures. I have labeled them A, B, and C. And in the chat, you will tell me what what class or what functional group is present in all of them. Okay. What functional group is present in all of them, A, B, and C. Okay. So which one of them is, let us say, is there any haloalkene that you can see, or alcohol, or phenol, or carboxylic acid? Okay. So just do that real fast. Then send me in the chat. Okay, correct, Faisal. Okay, go on with the B and then last one, C. Amalia, I'm waiting for your answers. I have not got any answers from you till now. Okay, what about A? B and C you have correctly recognized. What about A? You need some help, Amalia?
Yes, sir.
Yeah, okay. So carbon and hydrogens, right? These are the normal things. You don't have to look at carbon and hydrogen. Is there anything other than carbon and hydrogen in this particular structure? Is there anything else? What can you see? First of all, what you can do is you can highlight this part. Okay. You'll say, okay, fine, this is carbon, this is hydrogen. I don't need this part. Let us move on to the next atom. This is carbon and it is attached with hydrogens here. And it is also attached with hydrogens in this part. Now, if you see this thing, if you see this here, this is a OH group, right? Right, Amalia?
Yes, sir.
So what functional group is this? OH?
It's a hydroxyl group.
Hydroxyl group. Okay. So hydroxyl group, and it is the name of the functional group or the name of the class of the compound is alcohol, right?
Yes, sir.
Alcohol. And Faisal, this is aldehyde, not ketone. Can you see it now? Here it is H now. If this was CH3 here also, then it would have been ketone, right? Faisal?
Yes, sir. I didn't notice that one.
Okay, fine. No problem. Okay. So this is aldehyde. And both of you have recognized the last one very correctly, that it is carboxylic acid. Okay. Most of you, both of you must have heard this term oxidation number. Right? Yes or no? Tell me.
Yes, sir.
Yes, sir.
Right. So I want both of you to calculate the oxidation number. In the sense, I'm mean that I will tell you how to calculate the oxidation number for both of them. Okay. So for all the carbon which are colored in blue, I will calculate the oxidation number. I will do this for one. I will do it for one, and then I will ask you guys. Okay, for the BNC. So the way in which I am going to calculate oxidation number for these carbon atoms, it is going to be a bit different. So please pay attention. Okay, please pay attention. I am going to ask you who is more electronegative. Okay, who is more electronegative? We have a blue carbon and the black carbon. What do you think? If I talk about the electronegativity of carbon and carbon, they both the carbons will have the same electronegativity. Yes or no?
Yes,
Both the
sir.
carbons will have, right? Both the carbons will have same electronegativity. Okay, fine. That means there is no oxidation number or there is no oxidation state that is being carried by the blue one due to this black one. Okay, but when I talk about hydrogen and carbon, then what do you think? Which is more electronegative, carbon or hydrogen? Which is more electronegative?
Carbon.
Carbon.
Carbon, right? Carbon is more electronegative. If carbon is more electronegative, then you will assign for this particular bond -1 to carbon and +1 to hydrogen. Similarly, due to this bond, what will be the oxidation state for carbon?
-1.
-1, and the hydrogen will get a +1. Okay, so we are not interested very much in the hydrogens. I'm just giving that +1 and -1 so that you can see that it is neutral, still neutral. Okay. Now, what do you think? If I write OH, what charge should I give it? If I write OH, OH generally has what
Minus.
charge? OH minus, right? You recognize this part, OH negative, right? That means this particular entity, OH, it will have -1. And if it is having -1, the carbon should have +1 oxidation state. Is this clear?
Yes, sir.
Yes, sir.
Okay, fine. So now you tell me, now carbon has -1, -1, and +1. These are the oxidation states. And from this carbon, it is 0. And from this carbon, both these carbon, due to this bond, it is 0 and 0. Okay. So what do you think will be the complete oxidation state of carbon? It is -1, -1, +1. If you add all of them, -1, -1, +1. This will be equal to -1, right? Right, -1. Okay. Fine. Now let me erase all these things. I hope you understood how to calculate. Yes or no? Please tell me.
Yes, sir.
Right. Okay. So this alcohol, the oxidation state at alcohol is what? It is -1. It has the oxidation state -1. Okay. Now let us move on to aldehyde. So what do you think? Due to this bond, the bond that I am going to highlight with red, due to this bond, this will have 0 and this will have 0. Is that right?
Yes, sir.
Okay. Now, what do you think about carbon and hydrogen? Which is more electronegative?
Carbon.
Carbon, it is more electronegative. Carbon is more electronegative. So that is why it will get -1 and hydrogen will get +1. Okay. Now, what about this O? What do you think? What will be the oxidation state of this O entity?
-1.
Here, I will tell you how to see. Okay. Let us do something like this. Let us look at this OH negative. Okay, OH negative, right? OH negative. Now, in this OH negative, what do you think will be the oxidation state of hydrogen? It will be +1, right?
Yes, sir.
Okay, then what should be the oxidation state of oxygen?
X + 1 is equal to -1.
Sorry, and X + 1, it is equal to -1. That is why you can see X will be equal to -2. Okay. Did Amalya understand this? Okay. Fatima and
Yes,
Abir
sir.
are also here. Okay. Welcome, guys. Assalamu alaikum. Ramadan Mubarak. And why are you guys late, huh? You guys are still forgetting. Ye aakhri ho gaya hai, bilkul. Like you have exams coming on and still you forget that there is a chemistry class on Saturday and Sundays. Abir and Fatima.
No, sir, I became little late.
You became little late from what?
When I was outside, I came home.
Why were you outside? रोजा नहीं रखा है क्या आपने? बाहर घूम रहे हैं आप?
सर रखा है रोजा.
फिर? Okay. Fine. So, okay, fine. All of you, this O will have how much? It will have -2.
-2.
Okay. And due to that, carbon will have +2. Is that right? From these
Yes,
two
sir.
bonds. Okay. Amalya, Abir, and Fatima.
Yes, sir.
Fine, everyone? Okay. Fine.
Yes, sir.
Okay. We have a new student. Assalamu alaikum, Anshara. How are you? No, she is not our student. Seems like that. Okay, fine. So what will be the total? Yes, Anshara, tell me. For which class are you here, Anshara? No, वो नहीं है. So what will be the total? Oops. So now tell me what will be the total oxidation state? The oxidation state of carbon plus one, right? Plus one, है ना? Plus one. So let me delete all of these things and let me write for aldehyde. It is plus one. Okay. Now moving on to carboxylic acid. So carboxylic acid, due to this particular bond that we have here, this bond, it will be 0 and 0. Okay. Now due to these two bonds, it will be plus 2, right? And due to this OH negative, this will be minus 2, and this will be minus 1. That is why it will be plus 1. Is that right? Yes or no? Please tell me.
Yes, sir.
You understood this now? Faisal and Nabir and Fatima, all of you?
Yes, sir.
Yes, sir.
Okay, fine. So this will be plus 3. Carboxylic acid has the oxidation state that is plus 3. This is the most important thing that you have to remember. And I'm not saying that you have to understand. I am saying that you have to remember it. You cannot afford forgetting this part. Okay. What does it mean? It means that if I go from alcohol to aldehyde, if I go from, okay, now in this case, the control Z doesn't work. I don't know why it should be working. Okay. If I go from alcohol to aldehyde, that means I am doing oxidation. Yes or no? Right? Minus 1 to plus 1. Oxidation state is increasing. Similarly, from aldehyde to carboxylic acid also, this is oxidation. And if I go in this order, this will be reduction. And aldehyde to alcohols also is reduction. And if I go from alcohol to carboxylic acid, it is going to be also oxidation. But you can see that if I move from alcohol to carboxylic acid directly, that means, it means what? It means I have to use a strong oxidizing agent. Is it right? Yes or no?
Yes, sir.
Okay. So please remember this part. Please remember this part. Okay. Please remember this part, that alcohol to aldehyde, you can go and by using an oxidizing agent. Okay. One more thing you have to remember. For example, if you have an alcohol like this, CH3, carbon, CH3, and there is a hydrogen here. And there is a OH here. Okay. So this is what? This is a 2-degree alcohol. And if you do an oxidation reaction, PCC, let us use, and then you will be making CH3. The same carbon will be here and double bond O and CH3. Okay. Fine. Yes or no? Tell me. Okay. If you have 1-degree alcohol, you are going to make aldehyde. If you have 2-degree alcohol, you are going to make a ketone. Okay. 3-degree alcohol. In both the case, you will use PCC. And 3-degree alcohol, if you use PCC only, it will not give any reaction. And this will not come in your syllabus also. Okay. So 1-degree and 2-degree. Please remember this sequence also, this kind of ladder: alcohol, aldehyde, carboxylic acid. Hai na? So in here, we are using 1-degree alcohol. That is why we are making an aldehyde. Is that fine with everyone? Yes or no? Please tell me.
Yes, sir.
Yes. Okay, fine. So let us move on to the next part. Okay. So in this, I am going to talk about most of the name reaction. Okay, most of the name reaction, starting with our Rosen1 reduction. Okay, so in Rosen1 reduction, what happens? Okay, what type of molecule is this? This is acyl chloride. Okay, this is acyl chloride. Now, acyl chloride, when it is hydrogenated. So what are we doing here? We are giving hydrogen. That means this is a reduction reaction. Okay, so as soon as you see reduction, you should assume that there should be a H2 molecule. There should be some reduction going on, Rosen1 reduction. So in Rosen1 reduction, you can see that in this case, we have from here, we have -2. Cl will be always Cl negative. Okay, sorry, this will be +2 here, and here it will be +1, right? So the oxidation state of acyl chloride is +3. And if you look at the oxidation state of aldehyde, it is going to be how much? What is the oxidation state of aldehyde? What is the oxidation state of aldehyde?
+1.
+1.
+1. Hai na? So you can see that it is a reduction reaction. Yes or no? Can you see that? It is a reduction reaction. Yes or no?
Yes, sir.
Right. So it is Rosen1 reduction reaction. Okay. So let me just clear the ink from this slide. And also, what is the use of this PDBaSO4? It is why it is used. Why is PDBaSO4? You can be asked this question, why it is used. So if you are using a H2 molecule and you are reducing acyl chloride, there are chances that this acyl chloride will further reduce the aldehyde into alcohol. Okay, this is a chance. So to stop this reaction, PDBaSO4 is used. To stop this reaction, PDBaSO4 is used. Okay, so this is known as poison catalyst. Poison catalyst. Okay, so it performs the action of poison catalyst. That means a catalyst is usually something that speeds up the reaction, and a poison catalyst is something that stops a particular reaction. Okay, so what PDBaSO4 is doing, it is stopping this reaction from aldehyde going over to alcohol, because if I reduce aldehyde, I'm going to get alcohol. Okay, so is this clear with Rosen1 reduction? Please tell me yes or no.
Yes,
All the
sir.
things,
Yes, sir.
right? Acyl chloride to aldehyde. Please remember, acyl chloride to aldehyde only. Okay, acyl chloride to aldehyde. So I'm going to give you some questions, and then you will give me the answers. Okay, CH3, C double bond O, Cl. Wait a second. Let me write it a bit properly. How are you, Fatima? I don't hear Fatima. Fatima is here now. Fatima is here. Fatima, I can't hear you. What happened? Can't you move? Can't you unmute? Good. Ramzan Mubarak to you also. Where is Sania? Sania is not here today. Assalamu alaikum, Ahmed. How are you?
Yes, I'm doing good. How about you?
I'm good. I'm good. You were not present for past a few classes. Why? Yes, Ahmed, what happened? No answer. Okay. I hope everything is fine now.
Yes, it is.
So in this Rosen1 reduction, you don't have to do anything else. You just need to replace this chlorine with this hydrogen. Okay, you just need to replace this chlorine with hydrogen. So generally, you can also write here HCl. That will be a byproduct. Just giving you guys 2 minutes. Please complete this. It is a very easy questions. Okay, these three. Just need to replace Cl from Cl with hydrogen. Faisal, yes, Faisal, you want to say something, or are you done?
Done, sir.
Done, na? Okay, fine. Done. Very good. What about others? Done? Fatima?
Yes, sir.
Yes. Ahmed and Abir? Yes.
Yes, sir.
Okay, I hope you have written right answers only. Please make sure. This will be the first answer, and here you will have hydrogen. Okay, so this is clear with everyone, right? Let us move to the next reaction, that is, okay, I have written the questions here only. Okay, I forgot about this. Fine, no problem. What about Stefan reaction? I have written the reactions. Okay, fine. So Stefan reaction. Okay, now who will tell me what is the name of this compound? Which is R. There is a carbon. There's a triple bond with nitrogen. What is the name of this compound?
Nitriles.
Nitriles. Very good. Now there is another way in which you can calculate the oxidation state. Okay, calculate the oxidation state. Now this carbon and this R group, that means both of these are carbon. That means due to this particular bond, there will be a zero oxidation state and zero oxidation state, right? Zero oxidation state due to this bond in carbon atom. Okay, now in carbon and nitrogen, which is more electronegative? Between carbon and nitrogen, which is more electronegative?
Nitrogen.
Nitrogen, right? Nitrogen is more electronegative. And how many bonds is there? 3 bonds are there, right? So for each bond, you can assign a sign of +1 to carbon and -1 to nitrogen. And since there are 3 bonds, you can just multiply by 3. That means this carbon will have +3 oxidation state and the nitrogen will have -3 oxidation state in nitrite. Is this clear? Yes or no? Please tell me.
Yes.
What about others?
Yes, sir.
Yes, sir.
Okay,
Sir, could
everyone
you explain once?
explain once more. Okay, fine. We have carbon and here we have R group. So in R group, you understand, right? It will be any alkyl group, correct? So this will be 0 and this will be 0. No problem with that?
Yes, sir. No, sir.
Now let us see that there are 3 bonds and in here we have nitrogen. So due to this particular one bond, okay, this one bond here, carbon and nitrogen, which is more electronegative? Nitrogen, so -1 and here +1. Again, due to this particular bond, this bond, again, it's nitrogen will get -1, carbon will get +1. And due to this bond, carbon will get +1 and nitrogen will get -1. If you remember, you can also apply this in C double bond O, and you can say that due to this particular one bond, since oxygen is more electronegative, it will be -1, carbon will be +1. And due to this bond, -1 and +1. Still, you can see that oxygen is getting -2 and the carbon is getting, due to these 2 bonds, +2. Is this clear now?
Yes, sir.
Okay, fine. So again, we can see that it is +3 here. And what are we making? Aldehyde, right? We are making aldehyde, right? So aldehyde has a oxidation state of +1. So again, Stefan reaction also is a reduction reaction. Okay, it is also a reduction reaction. Now, in this case, there are 2 things happening. Okay, so we are breaking these 3 bonds, right? Within carbon and nitrogen. So we have to make 3 new bonds. Now, those 3 new bonds are being made 2 double bond. That means, sorry, 1 double bond with oxygen and a single bond with hydrogen. So we are breaking these bonds. So which bonds are broken? Broken bonds are carbon and nitrogen triple bond. So if 3 bonds are broken, there should be 3 bonds which are being made also. So what are the bonds that is being made? Carbon double bond O, and there's a carbon single bond hydrogen. These bonds are being made. Okay, any problem here? No, right? Okay, fine. So you can write the questions. Please write this.
So what happens to the nitrogen?
Sorry?
What happens to the nitrogen?
Nitrogen makes NH4Cl. Okay. There is one more step here. You just write a second step here. That is hydrolysis is also done. SN2 So initially what happens if I mix these three substances, I will get R CH double bond NH, which is known as imine. And after this, if I add water, that means if I do hydrolysis, I will get aldehyde. Okay. So let me write the second step here, H2O. So in general, the reaction goes like this: carbon, triple bond nitrogen. And if I add SN2, SnCl2 and HCl, I will be getting R, CH double bond NH. These are known as imines. Okay, these are known as imines. And then on further hydrolysis, some heat is also required because we have to boil this off, boil the water off. I will get R, carbon, double bond oxygen, and a hydrogen here. Okay, please write the answers. I hope you have written it like this: CH3, carbon, double bond O, and there should be a hydrogen here. And for this case, I will be making a benzene ring followed by a carbon double bond O and hydrogen. This is benzaldehyde. I hope you can recognize this benzaldehyde. Please write this down. Let me know if you're done.
Yes, sir.
Done. What about others? Done?
Yes, sir.
Yes. Okay. So we have seen two reduction reactions in which once we have acetyl chloride, acyl chloride, and in the other we have nitriles, and we are converting them to aldehyde. We are converting them to aldehydes. Okay. And in both the cases, you can see that I can also use aliphatic ones. That means pure CH3. That means we have no benzene ring, and we can also use aromatic ones. Next is a very simple reaction in which we use toluene. And then we use chromyl chloride. This is chromyl chloride. Okay. What is the name of this molecule? Can somebody tell me? CS2. This is the benzaldehyde. You must have seen this the previous slide. CS2, what will be the name of this compound? Okay, in the periodic table, what comes before sulfur? Just above sulfur, what is the element before sulfur? Just above sulfur, what is the element in periodic table?
Oxygen.
Oxygen, right? So it is very similar to CO2. This is carbon dioxide, and this will be carbon disulfide. Very good, sulfide. Okay, carbon disulfide. So I'm writing these things now because if the question comes in 2 marks or 1 mark or 3 marks, like you have to write some reaction, name reaction, then you have to write when toluene is treated with chromyl chloride in the presence of carbon disulfide. Okay. Then on further hydrolysis, it will give you benzaldehyde. Okay. So again, here there should be a hydrolysis part. Second step, it will be H3O plus. So H3O plus means acidic hydrolysis we are doing. We are doing acidic hydrolysis. Now, one important point is that, so there is an intermediate here. There is an intermediate here that also you should write. But don't focus so much on the intermediate, okay? Because this intermediate will take some time for you guys to get in the memory. So we have the whole situation here as we have in toluene, right? So this thing, all the benzene ring and CH, it is common between toluene and benzaldehyde. Till here you can remember very easily. Then we have two molecules of O, which is bonded to chromium, and this chromium is bonded to it is something like this. Let me write it like this. O, which is bonded to Cr, and this has an OH, and there are two Cl2s attached to it. Okay, so we write this as O. Oops. I've written two Cl2s only. So this will be Cl and Cl. Right. So here we have O, Cr, and then we have OH, Cl2. This chromium has a bond with oxygen, and these molecules OH and Cl2 also, OH and Cl2 also. Then on further hydrolysis, you will get benzaldehyde. other hydrolysis, you will get benzaldehyde. Okay. So for toluene to benzaldehyde, we have toluene to benzaldehyde. We have what? We have the, so you can also remember this as Etold reaction. How do you remember it? Etold. Okay. So you get a bit weird and say it is Etold reaction. Why it is Etold reaction? Because we are converting toluene to aldehyde. Okay. So it is Etold reaction. We are converting toluene to aldehyde, Etold reaction. Can you remember this reaction? Etold reaction, yes or no? Please tell me.
Yes, sir.
Yes. Okay, fine. So after this, we have the Gattermann-Koch reaction. We have the Gattermann-Koch reaction. In this case, also what we are preparing benzaldehyde. Okay, so please remember these two in a sequence: Etold and Gattermann-Koch. Etold and Gattermann-Koch. As soon as you remember Etold, you should also remember Gattermann-Koch reaction. Gattermann-Koch reaction. Okay, Gattermann-Koch reaction. How many of you know this word gutter?
Yes, sir.
What it is? It is sewer lines,
Sewage.
right? Yeah,
Yes.
sewage. Okay, fine. Now, in the road, you must see there is some kind of passage, right? From which people, they can go inside and clean the sewage. So
Yes.
this is that, what I can say, the cover of that passage looks like this. So that is gutter. So as soon as you see gutter, you will remember that this is the benzene ring. Okay, so gutter means gutter, and in the gutter you will have a sewage, and then you will have a cover for that sewage, and that looks like benzene. That looks like benzene. Okay, that looks like benzene. Then you have coach, right? CO, the coach, and from the coach KO, you will remember CO, and then you have CH, that is HCl. Okay, so Gattermann-Koch reaction, you can remember all the three substrates, and the reagent also. Okay, so we have benzene, coach, benzene, that means that is the Gatter, and then you have coach, and you are making benzaldehyde that you can remember from Etold. So as soon as you remember Etold reaction, you should also remember there is one reaction, Gattermann-Koch. Etold, Gattermann-Koch. Both of these reactions, they have the same product, benzaldehyde. They have the same product, that is benzaldehyde. Is this clear? Yes or no? Please tell me. Can I
Yes,
move
sir.
on? Okay, Etold
Yes.
and Gattermann-Koch. So we are done with what? We're done with Rosen1 reduction, Stefan reaction. Both of these are reduction reactions. And after that, we are preparing benzaldehyde with Etold reaction and Gattermann-Koch reaction. Etold reaction and Gattermann-Koch reaction. Now moving on to some reactions of aldehyde and ketones. Okay, aldehyde and ketones. So this is Wolff-Kishner reaction. Wolff-Kishner reaction. What is happening in this reaction? Can somebody tell me? Oxidation is happening or reduction is happening? What do you guys think? What is happening here?
Reduction is happening.
Reduction is happening. Right? Reduction is happening. Okay. Now, one important point you should note here: Wolff-Kishner reduction. It is possible for both the cases. Okay. Oops, I went to Clements in reaction. Yeah. Wolff-Kishner reduction. So Wolff-Kishner reduction, it can be, you will have C double bond O. Okay. It doesn't matter whether you have aldehyde or ketone. For both the carbonyl compounds, you can do this Wolff-Kishner reaction. Okay. So let me write it somewhere here. Possible for both aldehyde and ketones. Okay. So in this, what is happening? You are getting these carbonyl compound, it is getting reduced. Okay. So what you can say, this O will go away, and then you will get two hydrogens. Okay. Now this may look like a particular dance form of India. Which dance form is this? Which dance form is this? Don't know. Okay. In which dance forms do people have their hands like this? Tell me.
Punjabi dance.
Punjabi
Bhangra.
dance. Yes, Bhangra, right? So Wolff-Kishner is like Bhangra. Wolff-Kishner is like Bhangra, right? You will remove the O and you will add the hydrogens. You will remove the O and you will add the hydrogens. And how can you remember hydrogens? You can remember hydrogens with hands, right? Hydrogen with the hands. Can you guys remember now Wolff-Kishner reduction? Yes or no? Please tell me.
Yes, sir.
Okay. So again, I have to write out possible for both aldehyde and ketones. Okay, so let me just write a few reactions and then you can, let me see, do I have nothing? I don't have anything. CS3, C double bond O, hydrogen. Okay, or let me write what are these particular things. So what is NH2, NH2? Does anyone know the name of NH2, NH2? It says hydrazine. Hydrazine. KOH, I hope you know the name. What is KOH? Potassium hydroxide, right?
Hydroxide, yes, sir.
Yeah. And this is ethylene glycol. Ethylene glycol. Okay, ethylene glycol. So you just write, these are all these particular reagents are being used. I'm just using this comma to mark it. And what else can we use? We can also have a benzene ring. One more thing you can see that it is done in basic medium. Let me know if you're done.
So you have to write ethylene glycol as well.
No, don't try. Have to write, and just you can write. You should write that this particular molecule is ethylene glycol. Okay, because if a question comes, write a short note on Wolff-Kishner reaction. Then you will say that if a carbonyl compound, of aldehyde or ketone is treated with hydrazine in the presence of KOH and ethylene glycol, then the carbonyl group, it converts to, or it gets reduced to CH2. Okay, gets reduced to CH2. So basically ethylene glycol, it is used because we have to boil this, like, and boil in the sense that we have to at least go to 200 degrees Celsius. Okay, so if we are using a solvent which is water, then we can't go to 200 degrees Celsius, right? But ethylene glycol, you can see there are two OH groups, and these two OH groups, they will have hydrogen bonding. And that is why this is a high boiling solvent. So it has a very high boiling point, and we can use 200 degrees Celsius. If I use ethylene glycol, we can go up to 200 degrees Celsius. Okay, so we are not using water, we are using ethylene glycol. So if you start to study chemistry in college, then you will be asked ethylene glycol used in Wolff-Kishner reaction, but not water. Then you have to answer, because in Wolff-Kishner reaction, we have to heat this up till 200 degrees Celsius, and water boils at 100 degrees Celsius. So if we use water, the water will be boiled off before the reaction is even completed. Hence, we use a high boiling solvent like ethylene glycol to easily get to 200 degrees Celsius. Okay. So you must have got CS3 and CS3 here. And in this, you must have got toluene.
Yes, sir.
Right. Fine. Let us move on. Now, again, this reaction and this reaction. What is common between Wolff-Kishner and Clemenson? Okay. Is anyone trying to say something? I heard somebody's mic off. No. Okay. So what is similar between Clemenson
Reactor is same. And the product is
Yeah.
same.
Yes. So same thing, right? Same things. Same thing is happening. But tell me, what is the difference now? Don't tell me the reagents are different. Tell me a very distinct difference between Wolff-Kishner and Clemenson. Okay, you have seen Clemenson. I think you have Wolff-Kishner in your notebook. Tell me. Try
in
to
this
see.
reaction, there is no heat.
Okay. What else? It is not cold now, so I can't say it is like there is something completely opposite. Amalya, no, कुछ भी मत बोलो. Amalya, don't say just anything. Okay. So these two reactions, Clemenson and Wolff-Kishner, these are completely opposite reactions. Okay. Yes, yes, correct, Fatima. Okay. So the thing is that we have here, what is this? HCl, right? So this is in acidic medium. Okay. Fine, Faisal, Abir, and Ahmed. So
Yes,
this is in
sir.
acidic medium, and Wolff-Kishner is in basic medium. Wolff-Kishner is in basic medium. Okay. Clemenson is in acidic medium and Wolff-Kishner is in basic medium. So again, you can have some, you can write a few things. Okay, how will you write this reaction? If they ask you to write a short note, then you will say the carbonyl group of aldehyde and ketones is reduced to CH2 on treatment with zinc amalgam and concentrated hydrochloric acid, concentrated hydrochloric acid. Okay. Okay. In this case also, no, please remember this KOH, it is also concentrated. Okay. It is also going to be concentrated. Also, sometimes you will see that there is 50% KOH written or 50% NaOH written. So don't worry with that. 50% is a very high concentration. Okay. 50% is a very high concentration. Okay. Moving on. So Clemenson reduction and Wolff-Kishner reaction, both of them are quite similar. So I'm not, okay, let us write one reaction at least. CH3, C double bond O, CH3, and I'm treating this with zinc Hg in the presence of aqueous HCl. Okay, aqueous HCl. And as you can see here, since we are not using any heat, I'm using water. I'm not using a high boiling solvent. I'm using just water. Okay. So in this case, you just need to remove this double bond O and add the hydrogens. Add single bonded hydrogens. Write this down. Let me know if you're done. Then we will move to the next reaction.
Done, sir.
Done. All of you done?
Yes, sir.
Yes, sir.
Yes. Okay. Ahmed, write and tell me if you're done. Ahmed, done?
No, sir.
No, not done. Okay.
Yes, sir.
Okay. Clemenson. Then we have Cannizzaro reaction. Okay. In Cannizzaro reaction, you can see that we have one molecule. I mean, this is not one molecule. Rather, we would be using. If I want to balance this reaction, I have to write here 2. Okay, I have to write here 2. But we are using one molecule in the reaction container. Okay, so I'm just adding benzaldehyde. I just have benzaldehyde. Okay, I just have benzaldehyde. And what is happening? I am treating this with NaOH and heat. I'm treating this with NaOH and heat. In this case also, like in Cannizzaro also, NaOH is going to be concentrated. Okay, it's going to be concentrated. Here also you can use 50% NaOH. Okay, you can see what will happen if I treat benzaldehyde with 50% of NaOH with some heat and acid work. Acid workup means you are using H2O in the presence of H plus. Okay, H2O in the presence of H plus ions. Okay, now we have benzaldehyde. This is double bond O. Oxidation state is +1. For carboxylic acid, the oxidation state is +3. And we are getting here alcohol. For this, the oxidation state is -1. Is this clear? Yes or no? We have already seen the oxidation states.
Yes, sir.
Now, what type of reaction is this? In which a molecule is also getting oxidized and it is also getting reduced.
Redox reaction.
Every reaction is a redox reaction. A special type of redox reaction in which a molecule, a species is getting itself, it is also getting reduced and it is also getting oxidized simultaneously. Generally, what happens? Two different molecules. One molecule gets oxidized, the other gets reduced, right? In this, we have one molecule and it is getting oxidized also, it is also getting reduced. It is an example of disproportionation reaction. Disproportionation reaction. Do you guys remember this word? Disproportionation,
Yes, sir. Yes, sir.
right? This is an example of disproportionation reaction. So in which benzaldehyde, not only benzaldehyde. Now in this case, you have to remember a very important point. Okay, a very important point. You can use aldehydes. You can use any aldehyde that does not have alpha hydrogen. You understand the meaning of alpha hydrogen, guys? Yes or no? Please tell me.
Sir.
Yes. Okay. So I'm writing a few. Okay. All of you understand now what is alpha hydrogen? No, I'm not. Okay, fine. Yes or no, please answer something.
Yes, sir.
Do you know? What about others? Is there anyone who doesn't know what is alpha hydrogen? Please tell me. सबको आता है. Amalya, tell me what is alpha hydrogen? Malya.
This is a hydrogen and an alpha carbon.
Okay, fine. So 1, 2, 3, 4. Which is the alpha carbon here in the A structure? Which is the alpha carbon?
Is it 1?
No, it is 2. See, first of all, whenever you have alpha carbon or hydrogen, you will try to recognize the functional group. So I hope you can see that the functional group is, oops, this is bad. Yeah, to highlight this with yellow color. This is the functional group, right? Yes or no?
Yes, sir.
Yes, sir.
Then the next carbon, this is alpha. And then you will have beta, and then you will have gamma, and so on. Okay, so this is going to be alpha carbon. It's going to be beta carbon. Okay, so I'm writing a few molecules. You tell me which of the following will give me Cannizzaro reaction. Will A give me Cannizzaro reaction? Yes or no? Please tell me.
Yes.
It will give. What is the condition? Aldehyde does not have alpha hydrogen. Aldehyde should not have alpha hydrogen. No? So this carbonate has alpha hydrogen. How will it give? Huh? Faisal?
Sir, I thought it should have
No,
alpha
it
hydrogen.
should not have. Okay, it should not have. Okay, it should not have. Tell me, will B give Cannizzaro? Yes or no?
No, sir.
Yes or no? What are you saying?
No, sir.
No.
No, it will not give. What about C? Will it give?
Yes, sir.
Yeah. C will give Cannizzaro reaction. Okay, C is going to give Cannizzaro reaction. Now, in this case, what happens in Cannizzaro reaction? We have aldehyde, an aldehyde which does not have alpha hydrogen. An aldehyde which does not contain alpha hydrogen, it undergoes self-oxidation and reduction. Okay, so disproportionation reaction means self-oxidation and reduction. It goes self-oxidation and reduction on treatment with alkali. On treatment with alkali NaOH that is concentrated. Then one molecule of the aldehyde, it gets converted into carboxylic acid, and the other molecule, it gets converted into alcohol. Okay, it gets converted into alcohol. Sometimes what you will see, rather than this particular molecule, rather than this carboxylic acid, you will see here Na positive. Okay, so you are making what? Now, since we have done the acid workup, that means we have added water. This Na plus will leave and you will get OH. So if this acid workup is not there, then you will be only getting this molecule. Okay, O, Na positive. Now, if I add water to this H2O in the presence of H plus, then what will happen? This Na plus will be substituted, and here you will get hydrogen. Okay, in place of Na plus, you will get hydrogen. That is carboxylic acid only, carboxylic acid. Is this clear? You understand what is the use of workup now? This acid workup, yes or no? Please tell me.
Yes, sir.
Can you repeat,
Okay,
sir?
okay, fine. So if you don't have the acid workup, you will get the sodium salt of carboxylic acid, which is this compound. Okay, Fatima? नहीं, अच्छा देखिए. So see what happens. You will get a, let us suppose you have a carboxylic acid only. Okay. And in this system, that means in our container, we will have NaOH also, yes or no? Will there be NaOH? Because we have added NaOH now. So NaOH will be there, right? Now, if NaOH will be there, then what will happen? These two can react with each other, right? And if these two react with each other, what you will get? Rather than getting carboxylic acid, you will get this hydrogen will be removed from here and this OH, and they will make water, and this carboxylic acid will convert into sodium salt of carboxylic acid. Okay. But if I change the condition to acidic workup, that means if I add acid and water, then this particular acid will react with NaOH, and here I will be getting this carboxylic acid only. Okay. So NaOH will now have a acid to react with rather than reacting with carboxylic acid. That is why we use acid workup. Okay, that is why we use acid workup. Okay, so let me just clear this whole thing and move back to Cannizzaro reaction. Okay, so I hope Cannizzaro reaction is clear with everyone. Yes or no?
Yes, sir.
Yes. Okay.
Yes, sir.
So one more molecule that can give Cannizzaro reaction is HCHO. Okay, so since this particular formaldehyde, right? Formaldehyde, it does not have even alpha carbon. So there is no question of alpha hydrogen. It only has one carbon that has the CHO group. Does not have any alpha carbon. So there is no question of alpha hydrogen. That's why it can also give you Cannizzaro reaction. And the products for this will be CH3OH, that is an alcohol of one carbon, and then you will get HCOOH. Okay. But if you are not doing acid workup, then you will get Na positive. Okay. Na positive. Or if you're using KOH, then you will rather get potassium salt of carboxylic acid. Okay, I hope you are okay with this much changes in the questions. If you're using NaOH, then what product? If KOH, then you will get potassium salt of carboxylic acid. Okay, if you don't do acid workup. Okay. So after Cannizzaro, there is another reaction which is very similar to, not very similar, it is like opposite to Cannizzaro, but you have to remember it with Cannizzaro reaction only. So we have Cannizzaro reaction, and the other reaction is aldol condensation. Okay, Cannizzaro and aldol. What is the similarity that you can see? The similarity you can see that we are both using NaOH in this case, right? We are using NaOH in both the cases, and we are using heat in both the cases, and we are using acid workup, that is H2O. H2O is again here workup. Okay, H2O is again here workup. The only difference is that this NaOH is going to be dilute. Okay, this NaOH is going to be dilute. Is this clear? Yes or no? First of all, tell me.
Yes, sir.
Yes. And the other thing is that aldol reaction, it will happen if the aldehyde or ketone, they should have one alpha hydrogen. Okay, aldehyde and or ketones, whatever you are using, ketones should have alpha hydrogen. Okay, so this is a necessary condition for aldol condensation. Now, before moving on and writing the whole aldol condensation reaction, which is this reaction, there's another reaction which is known as aldol reaction. Okay, aldol reaction. So let me show what happens if we don't use heat. Okay, before heating, what happens? So when we are heating this this product, if we don't heat, then we will get a product which is, there will be R group, and you will have all the same things. This carbon atom, okay, which is bonded to this carbon atom here. Okay, this carbon atom, then again you are having C double bond O and H. And this carbon will get a OH group attached here. Is this clear? First of all, tell me. You have this hydrogen here as it is. So first thing is that you have to, first of all, let me clear all the ink. First of all, you need to add both the things, okay? Both the molecules, you have to add it. Let me show how you add it. So this here, it will be CH3, right? There will be CH3 here. So till here, everything is fine. No problem till here. Yes or no? Please tell me.
Yes, sir.
No problem. Okay, no problem. Now what happens? This hydrogen, it will go to oxygen here. इसके लिए हमको ऊपर बनाना चाहिए था. This hydrogen will go to this oxygen. Okay, this hydrogen is going to this oxygen, and this carbon will go to this carbon. Okay, this carbon will go to this carbon. So you have R, C double bond O, and there is a hydrogen here. Plus you have CH2 and this hydrogen. So hydrogen to oxygen and this carbon to hydrogen. So this type of bond is being formed. Okay, this type of bond is being formed. So first of all, you need to add these two things. You need to add the two things here. So you have pen and you have R. Now this carbon atom, it has oxygen, and this hydrogen is attacking on this oxygen. So you will attach it here. Then you have a hydrogen molecule, and this carbon is now getting attached to this carbon atom. Okay, now getting attached to this carbon atom, which has two hydrogen atoms. Now the third hydrogen atom, it went to the oxygen, and then you have double bond O and H. Okay, C double bond O and H. Is this clear till here? Yes or no? Please tell me.
Yes, sir.
Okay, now this is our carbon, which is functional group. This is alpha carbon, this is beta carbon. So you have to make a beta hydroxyaldehyde. Beta hydroxyaldehyde, since we are using aldehyde here. Okay, if you are using ketone, you will make a beta hydroxy ketone. So please tell me, is this clear till here? Can you make a beta hydroxyaldehyde or ketone if I give you some molecules? So let me give you some molecules. Okay, and then you will make. So I will start with a very simple one. That is, first of all, tell me, will this molecule show aldol reaction? Yes or no?
No, sir.
No. What about this molecule?
Yes, sir.
Yes. Which is this is our carbon, right? This is the functional group. This
No,
is the
sir.
alpha carbon. है ना? यहाँ पे तो कुछ hydrogen ही नहीं है. Okay, but this compound will show, right? CH2, CHO. फातिमा, अमलिया, आप लोग को आ रहा है? Yes, Amalia.
Yes, sir.
Yes, okay. So you tell me, guys. So this will not show. This will also not show. What about this one? Will this show? Yes or no? Please tell me.
Yes, sir.
Yes, this will show aldol. Why? Because we have alpha carbon, which has hydrogen. What about this one? Will it show?
Yes, sir.
Which is the alpha carbon? This is the functional group now. This is the alpha carbon, right? It does not have any hydrogen. Yes or no?
Yes, sir.
Yes, sir.
Yeah, so this will also not show. Oops. This will also not show any aldol condensation reaction. Okay, so let me just clear this thing. And let me give you guys some molecule. You have to make beta hydroxyaldehyde or ketone. Simple one, CH3, CHO, okay, plus, okay, let me write it like this. Whenever you have aldol condensation reaction, you try to write it in this way, C double bond O and H. So they will just give you this particular molecule, and they will ask you to do aldol condensation. So whenever you are doing aldol condensation, please remember that you need two molecules. Okay, you always need two molecules. So even though they are giving you just this one particular molecule, you can write one more molecule of the same formula, and you will write it like this: CH2, and there will be a hydrogen here, and there will be C double bond O and hydrogen. Okay, why can I write both of these molecules which are same? Why am I writing this? Because I need that in the reaction. And if I have a reaction container, in that I will not have one molecule of a particular substance. Rather, I will have many molecules of a particular substance. Okay, so in this case, what you will do, this hydrogen will go to oxygen, and this carbon will go to this carbon, okay? And then you are going to make a beta hydroxy aldehyde. Now things will get a bit complex, but don't get confused. We'll have C double bond O and CH3. So in this case, you have a ketone, but again, you are going to make the same molecule twice. You'll make it here like this. Again, CH2, a hydrogen here, okay, a hydrogen here, and then you will have carbon, double bond, CH3. Again, this hydrogen will get attached. Okay, now these arrow that I am making, these are not curved arrow of reaction mechanism, okay? So I'm just showing where this hydrogen is going to go. And this carbon will attack here, okay? This carbon will attack here.
Yes, sir.
Done. You have written the beta hydroxyaldehyde, yeah, and beta hydroxy ketone for both the things.
Yes, sir.
What about others? Please go step by step. First of all, write the CH3, then this carbon, and then this oxygen. After that, only go to this molecule, okay? Start with CH3, then go to carbon with OH, okay? And now this carbon has a hydrogen, you make the hydrogen here. And then you attach this with the next carbon, that is CH2. Okay, then again, the next carbon, which is C double bond O and hydrogen. Okay, no problem. Is there any problem? No, I think you can do the similar thing here also. You will have CH3, then move to the next carbon, and then you go and write OH. And after that, you make the CH3 here, which is present. Then you go to the next molecule, that is CH2. And then you have C double bond O, CH3. Is this clear, yes or no?
Sir, I did not do this.
You did not write this. What did you write then?
Sir, I removed water also from there.
You also remove water? Okay,
Yeah,
so you have
from
written
alpha and beta.
okay, from these two carbon. Okay, fine. But I asked you to make beta hydroxy first. Okay, so first of all, you have to know how to make beta hydroxy molecules. Okay, please
Yes.
write this down. All of you are done?
No, sir.
Please write, please write. There are a few slides to go.
Yes, sir. Done.
Done, all of you done? Is there anyone who is still writing? Amalia, are you done?
Yes, sir.
And we are just used or we are not used to have water. So we are getting beta hydroxy molecules. Okay. So if I take this beta hydroxy molecule, that is CH3.
Sir, your voice is low.
Okay, my voice is low. What about now?
Yes,
Is it fine?
Yes, it's fine.
Okay, fine. Then we have CH, which has OH molecule. Then we have CH, and then you write one more hydrogen here. And what do we have? We have CHO, right? We have CHO. Okay, so this is the beta hydroxy molecule. If I heat this, what will happen? If I heat this, water will be removed. What will be removed? What will be removed, guys?
Water.
Water will be removed. Okay. So if you are removing water, you can see this water here, H2O. And then you will get, so you're moving one bond from this carbon. alpha and beta carbon, we are removing 1 bond from both of them. So you will get a CH double bond, CH single bond, CHO. If I look at this molecule here, we have CH3 carbon, OH bonded to CH3. Then we have a CH and hydrogen. Right. And after that, what do we have? We have C double bond O, and there is a CH3 molecule here. And if you heat this, then again, this water will be removed and you will get CH3 carbon with a CH3 group here. And a double bond between alpha and beta carbons. And then single bond C double bond O, CH3. So please write this down. Let me know if you're done. Done, guys?
Yes, sir.
Then we have the last, I think, yeah, this is the last reaction, HVZ reaction. Okay, HVZ reaction, Helmholtz-Zillowski reaction. Helmholtz-Zillowski reaction. Okay, any idea where was this guy from? Huh?
No, sir.
No idea. Hafir is writing. I was thinking of this answer only. He's saying that he is Ukraine's president, Zelensky. No, he's not that guy. That guy is not a chemist. He's a comedian. Right, Abir? Okay. So at that time, I think you must know that Ukraine and many other countries, they were in as a part of the Soviet Union, right? So he was a Russian chemist, you can say, yeah. His name was Nikolai Zillowski. He was a Russian chemist. Okay. So Helmholtz-Zillowski reaction. In this, what happens? You need some alpha hydrogen. If you have a carboxylic acid with alpha hydrogen, we need to have carboxylic acid with some alpha hydrogen, with at least one alpha hydrogen. Okay. And in this alpha position, what happens? If we add PBr3 or if we add phosphorus with Br2, okay, phosphorus with Br2, anything you can add PBr3 and Br2, or you can add phosphorus with Br2, then what will happen? You will get a Br group attached, in the alpha position. This is one of the very most important reaction, Helmholtz-Zillowski reaction, okay? And in this case, in which of the carbon the Br will get attached? Tell me. In which carbon will the Br attach? Which carbon I have? अरे I have labeled it to alpha carbon बोल रहे हैं आप लोग. 1 2 3 4 5 6 में बताइए ना. Tell me.
2.
2.
Yeah. Okay. Br. If I have CH3, CH2, COOH, and P, Br2, H2O. Then tell me, in which carbon will the Br group attached? The CH2 or the CH3? Which carbon?
CH2.
CH2 carbon, right? So CH2 carbon will become CH and there will be Br group attached. You will have COOH. Okay. So this is Helmholtz-Zillowski reaction. Now let us move on to the chemical tests. Okay. So the first is 2,4-dinitrophenylhydrazine, and the important part with this 2,4-dinitrophenylhydrazine is that what do we test?
We don't have to write that.
Why do you want to write these things? Tell me ना. You have your notes already, right? आप बस ये लिख लीजिए ना, इसको लिख लीजिए आप. Okay. then you will know that what portions you have to study. Acha, moving on. So we have 2,4-dinitrophenylhydrazine. So this is used to have tests for this test for carbonyl. So if we have any compound A and I react this reagent with this A, I have a compound. You have been given a particular solution and you have been asked to do a test for carbonyl. So you will go and fetch up 2,4-dinitrophenylhydrazine. You will add dinitrophenylhydrazine in that particular sample that you have been given. And if it gives a positive result, okay, we'll see what is this positive result. Then you will see that this A molecule, it has some carbonyl group. Either it is aldehyde or it is ketone. It is aldehyde or ketone. Okay. So first of all, what is? So if you have any carbonyl compound and if you react with 2,4-dinitrophenylhydrazine. So phenylhydrazine is this part. NH2NH okay. We have NH2 NH PH phenyl and 2,4-dinitro, then you can add 2 and the second and the fourth position you can add nitro group and you will get 2,4-dinitrophenylhydrazine. You can also call this as 2,4-DNP. Okay. In short, it is known as 2,4-DNP. Then what product do you get? You get a derivative of 2,4-dinitrophenylhydrazine, which is orange in color. It is orange in color. This is not a 2,4-dinitrophenylhydrazine derivative, or it is, you can just remove this 2,4-dinitrophenylhydrazine. In place of hydrazine, you can write hydrazone. Okay, so this is 2,4-dinitrophenylhydrazone, which is yellow in color. So this positive test is yellow color. So if you have any sample and you react with 2,4-DNP and you get yellow color, that means this A sample, it has which group? Carbonyl group. It has carbonyl group. Is this clear? Yes or no? Please tell me.
Yes.
Yes.
Okay. So the important thing, 2,4-DNP, it is used to test for carbon, and the positive result is yellow. The positive color is yellow PPT. Then we have tolerance test. Okay. So what is tolerance test used for? The tolerance test is used to distinguish. Now, once you have identified it as carbonyl carbon, they will ask whether it is aldehyde or ketone. Then you will say, okay, fine, I will do tolerance test. In tolerance test, what will happen? If you have aldehyde, you will get a silver medal. Okay. So gives positive result with aldehyde. Okay. With aldehyde. Now, to confirm tolerance test, we have another thing which is known as Fehling's test. So in Fehling test, what will happen? So again, to confirm it is aldehyde or not, you will have aldehyde, you will add Fehling solution, and the positive result is red-brown PPT. The positive result is red-brown PPT. Okay, so it also gives positive result with aldehyde. It gives positive result with aldehyde. Is this clear till here? Yes or no? Please tell me. The three things.
Yes.
The chapter is aldehyde, ketone, and carboxylic acid. So you are identifying for carbonyl compound. So now you know it can be either aldehyde or ketone. Then to test that, you will use tolerance test. So if tolerance test is given, that means it is aldehyde. If it is not given, that means it is a ketone. Then you will again do Fehling test. So if you are doing Fehling test, it is giving positive result, then it will be aldehyde. If it is not giving positive result, that means if it is not giving red-brown PPT, it is ketone. Then we have iodoform test that you can confirm. So iodoform test, it is a bit important because you will have ketones. Okay, so ketones will give iodoform test, but it should have a methyl group also. Okay, so this fragment, if it is present, COCH3 is present. If COCH3 is present, then you will have a positive iodoform test. Okay, so positive result with COCH3. That means ketone with CH3 group. Okay, is this clear? Yes or no? Please tell me. All the four tests are clear. Yes or no? Please tell me.
Yes, sir.
Yes.
Okay. Fine. So, okay. So don't write this. Don't write this. All of you can see this. Yes or no? Please tell me.
Yeah.
Yes, sir.
Okay. So propanol and propanone. What chemical test will you use to distinguish between these two? So we have aldehyde and we have ketone, right? Yes or no?
Yes.
Okay. So what will you do?
Tolerant.
Yeah, you can do tolerance test also. What else you can do? What else you can do?
Fellings test or
Okay.
iodoform.
Iodoform also we can do. And please remember that you can also do iodoform. How? If you look at propanone, propanone is CH3, C double bond O, and CH3, right? CH3, C double bond O, CH3. That means you have this fragment of COCH3. Okay. COCH3 fragment you have, that is a ketone with a CH3 group. That means iodoform test will also give you a positive result. Okay, a positive result. What about this second one, acetophenone and benzophenone? What is the difference between acetophenone and benzophenone? Can you write the structures? Now, acetophenone is what? Tell me. A benzene ring. And after that, what do we have after that? Benzene ring. Then what will be benzophenone? What will be benzophenone? Acetophenone is this. What will be benzophenone? Okay. You have acetophenone? Nobody remember till now. Benzophenone. So we have benzene. Okay. And then you add phenone. That means you will have a ketone. Another benzene ring. Okay. So this part is phenone and this part is benzo. Is that clear? Yes or no? Please tell me.
Yes, sir.
Right. Okay. So now how will you distinguish which test? Tell me. Which test should we do? Again, iodoform will be done. COCH3 is there. Ketone with methyl group. Yes or no?
Yes, sir.
Iodoform. Here also iodoform. Okay. Then we have phenol and benzoic acid. ये तो नहीं पता होगा आप लोगों को, right? Phenol and benzoic acid. So please remember. So if you want to see if something has phenol or not, then what you will do, you will add Br2 in this. Okay. Now this phenol, it is very activating, and what happens? You will get a 2,4,6 tribromophenol. Okay, so you can use this reaction, and it is white PPT. Okay, this is white PPT. So either what do? You add Br2. Okay, so you can see that we can add Br2, and if we add Br2, we will get a molecule which is 2,4,6 tribromophenol, and it is white PPT. So if I get a white PPT, that means on adding Br2, that means it is phenol. Or what you can do, you can use a test for benzoic acid. What is benzoic acid? A benzene group with a COOH group. And what will you add here? You will add NaHCO3. Now, if you add NaHCO3, what will happen? This will react with benzene carboxylic acid, with benzene's carboxylic acid, making it COONA, and we'll get water plus CO2. Now, this CO2, it will go away with some effervescence, right? With some effervescence. So if you have any sample A and you are adding this molecule NaHCO3 and you are getting CO2, that means it is benzoic acid. That A is benzoic acid. And if you're not getting CO2, that means the molecule is phenol. Okay. So you have got two tests. Add Br2 to check whether it is phenol or not, and you can add NaHCO3 to check whether it is CO2 or not. Okay. So any one of these reactions you can write for phenol and benzoic acid. Is this clear? Yes or no? Please tell me.
Yes, sir.
Is this clear? Okay. So for benzoic acid, you will always remember NaOH CO3, and it gives effervescence, CO2 effervescence. So again, benzoic acid and ethyl benzoate. So you'll use the same reaction. Okay, you'll use the same reaction. Then you have pentane 2-on and you have pentane 3-on. Pentane 2-on and 3-on. So pentane 2-on, if you write the structure 1, 2, 3, 4, and 5, double bond O. Okay, so pentane 2-on, it has this fragment COCH3. This fragment COCH3. That means it is again iodoform test. Yes or no, guys? Iodoform?
Yes, sir.
Right. Benzaldehyde and acetophenone. Benzaldehyde and acetophenone. So acetophenone, again, it will have a COCH3 group. It will have a COCH3 group, right? It will have a COCH3 group. Is this clear?
Yes, sir.
Okay. So this will be given by iodoform test. Now, ethanol and propanol. Ethanol and propanol. How will you distinguish between ethanol and propanol? So if you look at the structure of ethanol, it is going to be CH3C, double bond O, and hydrogen. Again, you can see that here you have COCH3 group, but in propanol, CH3, CH2, CHO. Okay, CH3, CH2, CHO. Now, in this case, we don't have COCH3, right? In this case, we don't have COCH3, we have COCH2. So this propanol, it will give me positive result for iodoform test. Clear? Yes or no? So you can see that iodoform test is of much use. Okay, it is used very much. Okay, it is used very much. Okay, is everyone done? Yes or no? Please tell me any doubt in any one of these. In any one of these things, tell me yes or no.
No, sir.
No doubts. Okay, no doubt. Okay. Okay. Fatima, why do you think this type of question will not come in board? They will give you this in 1 marks. They will give you this for 1 marks. Identify which test is used. They will not give you this many question. Very short answer type, 1 mark question ये दे देंगे आपको, है ना? Then you will be like, I had to remember just small names. Okay, so please, these tests are important. Okay. Now, you just take a screenshot of these 2 questions and then try it at home.
Yes, sir.
Okay. 3, 2, and 1. Done?
Yes, sir.
Yes.
Okay. Then tomorrow you have test for the same chapter. Okay. Now, one suggestion I will do, I will say that only you always start with questions. Okay. Please don't read anything